Good morning, students. Chapter 6, Work, Energy and Power. Yes, we will see some questions here today. Example 6.8. Yes, a car simulation typical condition is given. Okay, consider a typical simulation with a car of 1000 kg moving with a speed of 18 km per hour on a smooth road and colliding with a horizontal mounted spring of spring constant 6.25 to 10 raised to 3 Newton per meter. What is the maximum compression of the spring? See, this type of simulation is used to avoid car accidents. Manufacturers, while they are manufacturing cars, okay, to study or to modify braking system, they use such experiments. Okay, what is given? See, consider a typical simulation, a car of 1000 kg moving with a speed of 18 km per hour on a smooth road, okay, and colliding with a horizontally mounted spring or spring constant 6.25 to 10 raised to 3 Newton per meter, like this. See, here it is. It is spring like this. Okay, a car is moving in this direction. Clear about this? Okay, so yes, consider a typical simulation with a car of 1000 kg. So mass of car m is equal to, it is 1000 kg, moving with a speed of v is equal to, it is 18 km per hour. If you convert 18 km per hour, you will get 5 meter per second. On a smooth road, this road is smooth, so there is no friction force. Okay, and colliding with a horizontally mounted spring of spring constant means A is equal to, it is 6.25 into 10 raised to 3. It is Newton per meter. Okay, you have to find what is maximum compression of spring. X is equal to what? See what happens here. What happens here? Okay, yes, car is in motion. Yes, car is in motion. Car is in motion. Yes or no? So yes, car as it is in motion, it has some kinetic energy, that is K is equal to half mv square. This car is moving with kinetic energy, K is equal to half mv square. K is equal to half mv square. Now it is colliding with this spring. Now it is colliding with this spring. Yes, due to collision, its speed decreases. So its kinetic energy decreases. But due to kinetic energy of this vehicle, of this car, this spring, it is compressed. This spring is compressed. Yes or no? This spring is compressed like this. See, if it is another figure, okay, so yes, due to this car, the spring is compressed. Due to car, spring is compressed. Do you understand? Okay, so yes, initially this car, it is in motion, having some kinetic energy. It is colliding with this spring, collides with this spring, collides with this spring, and yes, up to this point, the spring is compressed. Up to this point, the spring is compressed. Means it is compressed by X. For example, it is compressed by X. Okay, so yes, during this situation, what we can say? Okay, yes, this kinetic energy of, according to law of conservation of energy, this kinetic energy of car is converted in elastic potential energy of spring, because due to collision, this spring compresses. This spring is compressed. This spring is compressed. In normal condition, it is not compressed or it is not stretched, so its elastic potential energy is 0. But when car is colliding, it is compressed. So there is some elastic potential energy in it. Okay, so according to law of conservation of energy, kinetic energy of car is equal to potential energy, elastic potential energy of spring. Clear about this? Yes, there is no friction force. There is no friction force, so there are no losses of energy. Clear about this? So here, how to write here? Kinetic energy of car is equal to elastic potential energy, elastic potential energy of spring, because here kinetic energy of car is converted in potential energy of spring. Kinetic energy is converted in elastic potential energy, is converted in elastic potential energy of spring. Clear about this? Okay, so yes, here we can say kinetic energy of car is equal to elastic potential energy of spring. What is kinetic energy of car? It is half mv square. What is elastic potential energy of spring? It is half kx square. Half cut, half cut. We have to find x. So x square is equal to, it is mv square upon k. M 1000. V square means 5 into 5 divided by k, it is 6.25 into 10 raised to 3. Clear about this? Clear about this? So yes, if you calculate this, you will get 4. So therefore, value of x is equal to 2 meter. Value of x is equal to 2 meter. So when this car of 1000, mass 1000 kg, moving with speed 18 km per hour, that is 5 meter per second, okay, is colliding with this spring. What is maximum compression of spring? Maximum compression of spring is x is equal to 2 meter when the surface is smooth. When the surface is smooth. Clear about this? Clear about this? Okay, so yes, it is one easy question in which we have to use law of conservation of energy. It is nothing but law of conservation of energy. Okay, initially car is moving, spring is uncompressed, so energy is of this car only. Finally, this spring is compressed. Car at maximum compression, it will be at rest condition. So yes, it is in compressed condition. So it has some potential energy. So simple, you have to use law of conservation of energy. Clear about this? Now we will see another question, that is example 6.8. Sorry, 6.9. Example 6.9. What is example 6.9? See, in example 6.8, taking the coefficient of friction to be 0.5. Taking the coefficient of friction to be 0.5. You have to find what is maximum compression of spring. You have to find what is maximum compression of spring. Similar question. See, here it is. Similar question. It is spring. It is car. Okay, it is moving in speedily. But now this surface is rough. Now this surface is rough. How to identify surface is rough? You are given coefficient of friction to be 0.5. Then you have to calculate what is maximum compression. Clear about this? Clear about this? Okay. So see, here, in example 6.8, taking the coefficient of friction to be 0.5, calculate maximum compression. During this system, what happens? See, yes, we have to use law of conservation of energy. That is, total initial energy is equal to total final energy. Total final energy. If at this point I have 100 joule of energy, if at this point I have 100 joule of energy, okay, then I am moving on rough surface, on friction surface, having some friction, on rough surface, having some friction. And for example, 40 joule energy is used against friction. 40 joule energy is used against friction. Then how much energy is remaining? 60 joule. So yes, that 60 joule is used to compress the spring. That 60 joule is used to compress the spring. So here what happens? See, this car having kinetic energy, that is half mv square. Okay, initial energy. Out of this energy, some part of energy is used against this friction force. Some part of energy is used against this friction force, and the remaining energy is used to compress the spring. Yes or no? Again, initially the car having some kinetic energy. Okay, as it is moving, some energy is used against this friction force, and the remaining energy is used to compress the spring. Yes or no? So yes, here according to law of conservation of energy, how to write statement? Okay, according to law of conservation, according to law of conservation of energy, according to law of conservation of energy, kinetic energy of car, kinetic energy of car is equal to work done against friction force plus elastic energy of spring You understand this equation, this relation? Initially car is moving, so it has some kinetic energy. Now as it is moving, this surface is rough, so obviously work done against friction force, and plus remaining energy is used to compress this spring. So yes, that remaining energy is in form of elastic energy of spring. So now how to make relation? It is half mv square is equal to work done against friction force. We are assuming that compression is x. Let compression of spring is x. So yes, block will move distance x. So work done against friction force is F into x plus it is half kx square. Clear about this? Now you have to put value and calculate x. See how? Again, kinetic energy of car half mv square. Work done against friction force, that is Fx. Work done means force into displacement. Okay, block is displaced by distance d. Spring is compressed by distance d. Okay, so it is Fx plus half kx square. Now put value. See, here it is. Half m, that is 1000, v, that is 5 into 5, is equal to f. Yes, f. What is f? See, first of all, we will put value of f. Okay, see, here it is. Half mv square is equal to f means mu into n x plus half kx square. Now n means what? Yes, n means what? Yes, we know that normal reaction is in upward direction, but mg is in downward direction. So it is half mv square is equal to mu. N is equal to, it is mg x plus half kx square. You know how to put value of n. Okay, now you know how to put value of n. So now we will put values. See, it is half m means 1000, v means 5 into 5 is equal to mu 0.5, n means 1000 into g means 10 into x we have to find. Okay, then yes, here it is plus half k means it is 6.25 into 10 raised to 3, and here it is x square. Clear about this? Clear about this? Okay, how to write this equation? Half mv square is equal to mu ngx plus half kx square plus half kx square. Okay, now how to find? See, half into 1000 into 5 into 5. Okay, half 1000 into 5 into 5, you will get it is 12500. 12500 is equal to 0.5 into 1000 into 10. So you will get 5000x plus half into 6.25 into 10 raised to 3 x square. So you will get is 3125. It is 3125 x square. It is 3125 x square. Clear about this? Now 125,000, 5000 and 3125 and 3125. If you take 625, if you divide this equation by 625, what you will get? 125,000 divided by 625, you will get 20. 5000 divided by 625, you will get 8x. And plus here 3125 divided by 625, 3125 divided by 625, you will get, it is 5x square. Clear about this? Okay, so yes, 5x square plus 8x is equal to 20. So I can write this equation as 5x square plus 8x minus 20 is equal to 0. It is quadratic equation. And now how to solve this quadratic equation that you know. How to solve this quadratic equation that you know. 5x square plus 8x minus 20 is equal to 0. See, we can use this method. X is equal to minus b plus or minus under root b square minus 4 ac. Yes or no? Divided by 2a. Divided by 2a. Minus b plus or minus under root b square minus 4ac upon 2a is equal to minus a plus or minus under root, it is 64, minus minus will become plus, it is 400 divided by it is 10. So it is minus a plus or minus 464 and its square root will be 21.54 divided by 10. So x is equal to this. Any doubt? Okay, now we can take two values. First, x is equal to minus 8 minus 21.54 divided by 10. But here x will be negative and it is not possible. And it is not possible. Okay, so here we will take this value. See, x is equal to is minus 8 plus 21.54 divided by 10. So x is equal to it is 13.54 divided by 10. So x is equal to 1.35. X is equal to 1.35. Clear about this? So yes, what is difference between these two questions? This friction force. If surface is rough, then that friction force is equal to 0. Then half mv square is equal to half kx square. That is for case 1. Yes or no? You understand about this question? Yes. In first case, you are given smooth road, and in second case, you are given a rough road. Okay. So yes, in rough road, some energy is used due to friction. Some energy is used due to friction. So see, in first case, what is maximum compression? 2 meter. In second case, maximum compression is 1.35 meter because some part of kinetic energy of car is used against friction force. So less energy is used to compress that spring. Clear about this? Right. Now see, next question, exercise 6.12. An electron and proton are detected in a cosmic ray experiment. The first with kinetic energy 10 kilo electrovolt and the second with 10 kilo electrovolt. Which is faster? Obtain ratio of that speeds. Obtain ratio of that speeds. See, I will give you a hint. An electron and proton are detected in a cosmic ray experiment. The first with kinetic energy 10 kilo electrovolt means first is electron. So kinetic energy of electron. Kinetic energy of electron. K is equal to, it is 10 kilo electrovolt. Clear about this? Yes, kinetic energy of electron, I can write like this. K is equal to, it is half m e, mass of electron, v e, speed of electron, whole square, is equal to 10 kilo means 10 raised to 3. Electrovolt means 1.6 into 10 raised to minus 19 joule. Yes, you are given. Yes, you are given. Okay. Now, similarly, an electron and proton are detected in a cosmic ray experiment. The first with kinetic energy 10 and second with means kinetic energy of proton. Kinetic energy of proton. Kinetic energy of proton. K is equal to, it is 100. It is 100 kilo electrovolt. Okay. So yes, it is half mp, mass of proton, Vp, speed of proton, whole square, is equal to, it is 100 into kilo means 10 raised to 3, 1.6 into 10 raised to minus 19 joule. Clear about this? Okay. You have to find which one is faster and obtain the ratio of their speed. You have to obtain ratio of their speed. Let's see how to find this question, how to solve this question. We will take ratio of these two energies. We will take the ratio of these two energies. How? It is like this. Half m v square divided by half mp Vp square. Okay, right hand side is equal to 10, 10 raised to 3, 1.6, 10 raised to minus 90, divided by, here it is, 100, 10 raised to 3, 1.6 into 10 raised to minus 90. Clear about this? Half cut. 10 raised to 3, 10 raised to 3. 1.6, 1.6. 10 raised to minus 90, 10 raised to minus 90. Cut. Okay. So yes, we have ME VE square divided by MP VP square is equal to. It is 10 divided by 100 means it is 1 upon 10. Means it is 1 upon 10. Now VE square upon VP square is equal to 1 upon 10 MP Clear about this? So yes, VE upon VP. Here it is square. So if you want to find only VE upon VP, you have to take square root on both sides. So it is MP upon 10 upon 10. Clear about this? Okay. So yes, VE upon VP is equal to under mass of proton 1.67 into 10 raised to minus 27 divided by 10 ME 9.1 into 10 raised to minus 31. Clear about this? Okay. Now you have to do calculation. Okay. 1.67 into 10 raised to minus 27. 10 into 9.1 into 10 raised to minus 31 into 10 raised to minus 31. Calculate this. Find answer of VE upon VP. And from that you have to write which one is faster from relation. Yes, from relation you have to write your answer. Okay, which one is faster? Electron is faster or proton is faster? Okay, yes, you can easily compare that speed. Okay, and from that comparison you have to write your answer. Okay, we will see next question. That is the last for today. Next question is next question is constant force F is equal to minus I plus 2J plus 3K Newton is acting on body. What is work done by this force in moving the body a distance of 4 meters along Z axis? Yes, it is constant force. So yes, you are given F. A body is moving a distance of 4 meters along Z. So how to write displacement? Displacement is 4K caret. Why 4K caret? Because the body moving a distance of 4 meters along Z axis. So it is equal to 4K. Now what is work done by constant force? Work done by constant force. W is equal to F dot D is equal to F minus I caret plus 2J caret plus 3K caret dot D. Here it is only 4K caret. What is dot product? Yes, you know dot product. Product of X component plus product of Y component plus product of Z component. X component here, but here there is no X component, so 0. Y component, here it is no Y component, but Z component, here it is 3K and here it is 4K. So 3 into 4 it is 12 and K dot K is 1. So yes, it is 12 Newton meter, or we can say it is 12 Joule. It is one simple question. In which you have to find what is work done by constant force. Clear about this? So yes, in this lecture we have discussed about one question that is based on kinetic energy, one question that is based on work, and one question which is based on law of conservation of energy. Okay.